Hey, QED coders. This is Michael. Jana's not here this morning, but yeah, we have a brand new guest of the Discord joining us. So if you would like to join us on Discord, it's at immutablearchitecture.com. Come on in. Let's talk about the book. Let's talk about software design. So welcome. I see your screen name is Oba100.
It's a hex code, but you can call me Cabbage.
Oh, Cabbage. Okay. Very good to meet you, Cabbage. So
It's
yeah, I
great.
understand that you've started reading The Art of Immutable Architecture.
Yes, I actually finished the book a few
Ah,
weeks ago. I
excellent.
really enjoyed it, and the last few chapters were pretty much essential for understanding how it all ties together, right?
Ah, good, good.
Um, One of the things that I'm looking into is my application that I'm going to be building is actually uh, not, it doesn't really have a center. And so I'm looking to build a maybe alternative kind of Jinaga type implementation
Hmm.
in my uh, language of choice, which at this point is Rust.
Excellent.
Um, and so I'm curious, where would you start if you were re-implementing it
Hmm.
in a different language or in a different framework with those new expectations?
Yeah. Um, yeah. So I think yeah. Well, the way that yeah, the way that yeah. So I basically built this idea a number of times. It started with the peer-to-peer game engine, which I built in Java, um, and then I kind of modified things a little bit, and that's yeah, I called it the peer-to-peer correspondence engine, and that's where the name correspondence came from originally. And then I re-implemented that idea in .NET, and that was the correspondence framework. And that one was I got pretty far along. That's where I added the factual modeling language, and I could compile that into code and all that. Um, and then I started to think, what would correspondence look like if it were in JavaScript? And then threw out a whole bunch of things like the factual compiler, and then did everything with inline DSL. And then yeah, that was the first Jinaga, Jinaga JS as it's now called. And even Jinaga I've rewritten several times. That original uh, specification language internal DSL was pretty hard to teach people, and so finally got to the second generation specification language uh, in JavaScript. It was okay, but now the one that's more the fluent syntax I think is working really well. And then that came about because I was porting it to .NET, and so okay, what would Janaga look like in .NET? And started taking advantage of the .NET idioms, and then that informed specifications, which then re-informed the the JavaScript version. So, yeah, just bouncing back and forth between different languages and having different needs really helped it to grow. So all that to say, uh, I would actually recommend starting with building an application using the patterns and the techniques as described in the book, and then see what needs emerge, and how that surfaces best in your language of choice, your stack of choice. So I don't know Rust. I do have it on the backlog to support Rust one of these days, but it's not anytime soon. Um, but yeah, I would start with the application, knowing ahead of time that you intend to extract a framework from it, so that you don't bake your domain knowledge into your implementation. Um, you kind of know in your head where that line is, and then you can start to extract it. So in order to kind of inform where that line is, I think, yeah, if I kind of go back through that lineage, I had the factual modeling language in the .NET correspondence library that I compiled into .NET classes, and that was the line between application agnostic and the information about the application. You would model your application in that language. So I think what I would do is I would start with making a wish. What would it look like if I were to model my application in Rust? Actually build out a historical model in Rust. What are the immutable data structures? Like in .NET, they're records. Um, in TypeScript, you would just have everything passed into the constructor, and that would make it immutable. Um, ish. But yeah, so what would that look like in Rust, and then what would querying that look like in that language? And then I think once you've identified that seam, you can in one application project build from both sides of that seam. Build your model just on this side, and then build the replication, synchronization, eventual consistency, all that stuff on the other side. See how much you can get down here and have very little up here, and then you'll get to a point where you can say, okay, now I can extract pieces of this and start to build up a reusable library.
Okay, that makes a lot of sense. So what I'm hearing is start from the application needs with immutable architecture in mind,
Mm-hmm.
and don't try and build a framework quite yet until I've got a reasonable code base that I can start to see some patterns.
Yes, yeah, yeah. I think that would be the most successful strategy.
It's been fun because I've been designing my application in Jinaga
Hmm.
with the DSL that you've designed, and it's really helped me kind of sort out my domain
Oh,
before
good.
I put it into Rust. And I'm really impressed with how fast the development is moving because the domain logic consists of only my models and my queries.
Excellent. Yeah, I'm very happy to hear that. I Yeah, that was one of the design goals that kind of occurred later. But but yeah, certainly uh, has informed then the various decisions. Like right now, I'm studying Kafka, and in order to set up a Kafka cluster, you have to have all these configurations. You have to know how it works under the covers in order to be successful. I wanted to do exactly the opposite. I wanted you to be successful out of the box, just specifying your application and anything that it could do on your behalf. I wanted it to do, which leads to a very complex runtime. So the idea of computing the inverse of a specification in order to update your user interface. Um, that's the sort of thing that if the library didn't do that, you would have to do that with your application, and you would basically, as a developer, compute the inverse in your head and then code it. So,
Right.
when this happens, throw that event so that this thing updates. Um, but uh, but yeah, I'm really happy to hear that is becoming a reality for you.
Yeah, and it's been I had previously modeled it out my domain while I was reading your book.
Hmm.
Um, and it was helpful to have the immediate feedback of Jinaga where I just like wrote out some classes, wrote out the queries, and then started piecing into, this the word is escaping me. The prerequisite relationship. You used a
Hmm.
different word.
Yeah, predecessor and successor. Yeah,
Predecessor.
yeah.
Right. And I feel like with those pieces in mind, I was able to much easier, like my little graph that I wrote, my entities and my facts, and then the ability of Jinaga to give me that feedback of, hey, this doesn't work, try again. Like that helped me to mentalize and visualize it. And one of the features I'm actually interested in particular is this purge that you were talking about. And you mentioned you had a demo for that.
Yes, yes, indeed. Um, yeah, let me do a screen share, and I can show you what I've got so far. All right, so you should be seeing infinite screens, and then yeah, here we go. All right. looking for... Yeah, I'm looking for the right setting in OBS so that everybody else can see. Yeah, we'll use that one. Okay. All right. Yeah, so it kind of starts with the model. So here I've got the model of the blog example. So you can create a site. The site is created by a user and has a particular domain. And then I added these two facts here: site deleted, site purged, that refer, first of all, deleted back to the site, but then purged refers back to deleted. The idea being, let me go ahead and expand this a little bit. So you would usually do something like this with deletion, give it a date time so you can distinguish one deletion from another, and that way you can have site restored, and that would undo a deletion. And it pleases me to no end that that GitHub Copilot knows knows how to create facts that quickly. So yeah, the idea is that yeah, if you delete, you can undelete. So delete, restore, and so you clearly don't want to purge any information about a site that's just been deleted. Now, if you delete and then maybe time passes and you like empty your recycle bin, kind of a thing, and you decide, yes, I really do want to purge those that site. So then you have your blog site purged, and that refers back to the deleted. So it must have been deleted before it can be purged. But there's no additional property here because there's no way to undo the purge. This is a one-way street. So what I would really like to do is get those facts out of the replicator so that we can clean up that history. And so we can define purge conditions. And so with the purge conditions, I could say dot, and then I say when exists. So I'm going to purge something when something else exists. So I give it a specification that that tells it all about that. So when exists, model dot given, not mode, model dot given. So given a site, yeah. So given a site. So the site is the thing that I want to purge. Then I can do site arrow, and now I'm writing the condition for when I will actually purge that. So that's the wrong one. So when site dot successors, let's see, is it going to do this? So I want site purged. And then how do I get from purged back to the site? So I say purged dot deleted dot site. So that should have been it. Argument given. Let's see. I'm wondering if this is not the latest. The latest version of Jinaga. So I'm in replicator. Yeah, let me just make sure that I've got the latest. This one should be the latest version. So this would be, yeah, 6.3. Yeah, for some reason this thing is not finding. Well, let me just make sure that it's. All right, so there's model. Yeah, and now given. It's finding given. Okay, well, let's, oops, just for the sake of of the demo. Let's go back to this version of it. So I can do facts of type site purged dot join. Sometimes Copilot gets in the way. Join purged deleted site to site. That should be the same thing. It's still having trouble with that. What am I doing wrong? Okay, argument of type given is not assignable to parameter of type specification of. Oh, okay. I've got this, yeah, given match. There we go. Hey, that's better. Okay, so now I actually should be able to do site.successors. Yeah. Site purged. Where I take this join condition here. Okay, yeah, that cleans the code up a little bit. And now I don't need facts. Okay, yeah, so if I could just remember the API. Yeah, so this is the purge condition that I want to apply. So I'm going to purge a site when there exists a site purged. Purge deleted site. So so by applying that condition, I need to make sure that no matter what specification you run, you are going to not see these purged facts. So if the act of purging is visible to the application, then it violates the eventual consistency guarantees that Jinaga exists to give you. So so instead, what I want to do is make sure that you have in all of your specifications this condition, so that any purged facts would not even be visible to you through that specification. So let's run this thing. If I come over here, okay, so I have, yeah, I already have it running. So as I change the file here, it's restarting the replicator. So let me make a trivial change, hit save, and okay, well maybe it's not restarting the replicator. Let's just make sure that it's going to restart the replicator. Yeah, that's right. Okay, yeah, this one does the build first and then runs it. So yeah, it didn't restart the replicator. Okay, so now it has, and so now it has this purge condition. Oh, well, there's one more thing I need to do. Here, where I say, here is my Jinaga server.create. It's at this point that I need to set up the purge conditions. So I will bring those in from the blog model. And then rebuild and restart. And so now those purge conditions are applied to this particular Jinaga instance. And this handler is what I'm using to serve up that /Jinaga endpoint. So that is my replicator, and the replicator knows about these purge conditions. So let's suppose that I were to fill up this this repository or this replicator with some stuff. So I'm going to create sites, and So here I am sending that to my local replicator. I'm going to have a user with a fake public key. That's why I'm using this one, sans auth. And then let's go ahead and create just michaelperry.net. So push that button, and I see this 201 created. Now, there's another feature that I implemented quite recently, and that is the ability to export all your facts from your Postgres database. So using this, I can export that set of facts. So you can see the Jinaga user here and the blog site here for michaelperry.net. And so those are currently in the replicator. Now I want to get those myself, so from the application. So let's get sites, sans auth. So now here's the creator. I want to get all of the sites where the creator is that particular creator, and then just output their domains. So if I run this, I should get an error. Let's look at this error. The match for blog site is missing a purge condition. So we need to have this particular purge condition, or blog site purged, where purged deleted site refers back to that site. So this is enforcing the fact that I'm truly purging, or I'm truly not dependent upon purged facts. So if I take this and I add that condition here, so, and now instead of calling that P1, that was site. So let me put site in here. So now I have the same specification, but I am including that purge condition in the specification. So now it runs the specification. It gives me back michaelperry.net. And I can get rid of that one. I can do another create sites, and let's do 2. And that one was created. So now the old one was just michaelperry.net. If I run get sites again, boom, now we've got the 2 of them. Okay, so far this is just enforcing that I have the purge conditions on my specifications. But now let's actually use that purge condition. So after I create that site, let me go ahead and say, you know what, I want to delete that blog site delete. Is it delete or deleted? Let me come back here. Deleted, yes. So that is going to be, it's going to take the site deleted, the site, and deleted at. So there's my site, and then deleted at. That's going to be the current timestamp. So we'll do 2024. It is 11/21 T 14/25/05 Zulu. Okay, so we are going to delete the site. Now that's going to go ahead and create that deleted fact. But of course, deleted facts can be, rewound, because we can have a restored. So the purge condition is not just based on deleted. Let's go ahead and truly say, you know what, I really don't want this michaelperry2.net. I just want to purge that. So purged is a blog site purged and that refers back to the deleted. So that type should match right here, blog site purged, and the site deleted is called deleted. So with that, I'm actually creating the purged fact. So now with that and this this condition in place, I shouldn't see that result anymore. So the condition on this specification is removing the result, but the facts that I just created there are still in the replicator. I haven't actually performed the purge yet, so we can see here is that site. Here's the fact that it's been deleted. Here's the fact that it's been purged. So I want to actually perform the purge. Now, in order to demonstrate this, I need to add a few more facts. So let me create some posts on michaelperry2.net. Even though it's, as far as my application is concerned, been deleted and been purged, the fact is still there, and I can still say I'm going to add more successors to the site. And even if it wasn't, this would add that site back in because it's a merge type of an application. So I'm going to add a post with a couple of titles. Let's go ahead and create those. And now I can see there is the post with a couple of titles, all belonging to site F3, which is the one that was deleted here, or this was the Michael Perry 2 that was then deleted and then purged. So, so because this specification can never match the purged site, it would be perfectly safe for me to remove some of these facts. And now, because this is a merge-based system, I can't remove all the facts. I can't, for example, remove the knowledge that it was purged. Because if I removed this fact from the replicator, then if I were to run that create script again, it would recreate the site with the posts, and you would lose that eventual consistency because you couldn't then merge with something that did know about the purge and get to the same state. So so instead, I have to keep that one, but I can remove some of the other successors, like, for example, the posts. So right now, in order to do that, we need to come down here, and I will create an async function called call purge, and this will allow me to await. Now I need the actual Jinaga instance, so I'll get J out of the Jinaga server create. So I will say j.purge, and I give it no parameters because it knows from the purge conditions exactly what it's supposed to do. So now that I've got that, let me call that, and then well, don't need to be quite so final about it. It's still going to exit. I just want to see any errors that occur. Okay. So this will call the purge method on startup. So right now, you have to call the purge method whenever you want to purge things. I'll talk in a little bit about where that's going to be going. So let's stop this, build the replicator again now that it's calling purge, and there was no error reported. Let's see what happened. So let's export the facts, And now we can see we're back to user, site, and site 2. Wait a minute. Oh, interesting. Okay, so there appears to be a bug in my exports that is preventing me from doing this. Can I do this in JSON? Probably going to run into the same thing. Yeah. Okay. Well, I'll have to fix that. But the thing that has changed, if I were able to show you, is that I still have michaelperry2.net. I still have deleted, and I still have purged. But I have been able to remove the post title, and this other post title. So I've been able to actually purge the facts that are successors of the one that has met this purge condition. Where did the purge condition go? It's at the bottom. Yeah, and I know that it's safe to do so because the purge condition is guaranteed to be part of every specification in the application. So the application doesn't care about those successors that have been purged. Furthermore, it's only purging the ones that don't participate in this purge condition itself. So so that means if I learn about facts from some other place, they will still merge. It will still be a forward-only merge, and I won't have one thing that thinks that it's purged and another thing that thinks that it's not. I won't have deleted things just popping up again inside of a different replica. So that is the purge condition that I am going for. That should allow people to clean up their replicators, and then that addresses one of the biggest concerns that people have about Jinaga or about historical modeling in general, is that things tend to grow unbounded. Well, now you've got exactly the same capability as you would in a traditional database.
Great.
Now there is one other feature that I am currently working on, and that is right now you have to call purge in order to make this happen. What would be really awesome is that these purge conditions just take effect. So when I create a site purged fact, that tells the runtime, okay, right now it's fine to delete all the other other successors. So in addition to calling purge, you will also have the ability to, or it'll just automatically purge things that meet those purge conditions. So the reason for keeping purge and for implementing it in the first place is that if you come back later to your model and add new purge conditions, then it's not going to know to look for things that should be purged and go ahead and take care of them. So calling purge forces it to do that. So yeah, purge will eventually be just an administration function. You just call it whenever you know you're deploying a new version of the application. But yeah, for day-to-day operations, you don't need to call purge, or you won't in the future when I get this implemented. It'll just purge those facts as it learns about these purge triggers here. Something else really nice about that is that answers another question that I get all the time. You know, what about GDPR? What about the right to be forgotten? You build into your model a workflow where somebody requests. Yeah, they make a GDPR request. Okay, you record that as a fact, and now you can have a specification. Let's look for all the GDPR requests. Yeah, um, and somebody can review those, verify the identity of the requester, all that fun stuff, um, and then maybe there's uh, some other business process that you need to run. Um, you know, make uh, uh, make a request to some other stream, or some other system upstream, whatever. So you might have to do something with that request. But then when it's like, okay, we will comply with this request, then you create another successor to that request that says that we are going to comply. So the actual purge fact. And now you've got a purge condition looking for that one. And as soon as you insert that fact, then the data, except for the very root, which is like their public key, um, and the purge fact itself, and the workflow that led up to it, all of that is all of that is preserved, but all of the other information, the information that they wanted to remove from your system in the first place, that actually gets purged. Furthermore, because this is a fact, it now participates in all of these eventual consistency guarantees. So it's going to be pushed to the upstream replicator. It's going to be pulled down to any clients that are expecting site purged. And because you have to include site purged in all of your specifications, all of the clients are going to care about it. They're all going to have that in their specification. So that information will flow down to the clients, and as soon as they see it, if they've got this purge condition installed on the client, it disappears there too. So this becomes a mechanism for just propagating that GDPR compliance through the entire application, and still keeping the audit trail of the fact that it was requested, we followed up, and then we executed. So yeah, I think that pretty well solves that issue. And I'm pretty excited about that. I never thought that I would implement deleting data in an immutable database. The mechanism that I talk about in the book is all about um, rolling a replica or a rolling replicator. Stop sharing. There it is. So when you want to so periodically you would say, let's back this one up and let's put a new one in place, and then it would pull information into it. So that's still a useful technique, but that's not the only way to clean up your replicator. Now you've got this technique. You can put purge facts on the period pattern, and so okay, everything inside of this particular period, 7 years ago, that gets purged, and that can keep this replicator clean. And you can configure those purge conditions differently on different replicators. So so that means that you can have one replicator in the back that doesn't have a particular time-based purge condition. So that's the one that keeps information indefinitely, but maybe it still has the GDPR purge condition in it. And then you can control which facts are in which replicators. So keep some in cold storage, keep some live. I really like how that's turning out.
I think this is really cool, and it's impressive how cohesive the framework you've created is to be able to create this purge condition, and it's so intuitive from the design perspective of creating a reference point where you're like, all right, everything after this like isn't important anymore. We can remove that. Very cohesive framework. I'm really impressed.
Awesome, thanks. Yeah, that's the power of mathematics. Yeah, people have been asking for, okay, well, I understand that you have to do this immutable thing, but can you just let me delete data? I know what I'm doing. Let me do it. I said, well, but I can't prove that it's going to be safe. I said, oh, okay, now I can prove it. So yeah, that's yeah, I'm really happy with the way that turned out as well. So yeah, I'll be implementing that in the .NET version of the library. I'll be having it purge in real time, and yeah, that's I'll be rolling out those changes over the next couple of weeks. Cool. So yeah, as we're wrapping up, any final thoughts?
I had a number of questions pop into my mind, but I know you said we were shorter on time today, so I can parse through those and bring them up in another forum. But just want to say again, I'm really impressed by the framework, and I'm neck deep in a 5 framework, extremely complex domain-driven design piece of software, and this does not look like it's going to end up like that did.
Mm.
It's so hard to deal with. So I'm really excited to build something that relies on these mathematically sound concepts. That makes me excited.
Awesome, awesome. Yeah, and I'm really interested to see how the REST framework comes along. So yeah, please come back, share on Discord. Let's follow this up together.
Fantastic. Thank you so much.
All right, thanks, Cabbage, and yeah, I will see everyone next week.